Hey everyone, welcome to the networking module of the Azure Masterclass. And my goal for this module is to really explore the core fundamental virtual network functionalities, the connectivity I can establish with that virtual network, connecting things to it, and then controlling the flow of traffic. Things like the Azure load balancers, networking for Kubernetes, virtual WAN. I have other videos on those. I'm not going to cover those topics here. So let's kind of get into it. So when I think about a virtual network, this is the building block of all of the networking in Azure. A virtual network basically consists of one or more IP ranges. Now, typically, those IP ranges will be from the RFC 1918, the 10 dot, the 172.16, the 192.168. They don't have to be. If you were one of those kind of people around at the dawn of networking, and maybe you have your own kind of class B in some way, you could absolutely bring a portion of that network space to Azure. It doesn't mean it would work on the public internet. The only public IPs I can use from Azure are ones that Azure provides. I cannot bring my own public IP. But I could still use that IP space on the Azure network if I wanted to. If I was going to connect things in Azure to on-prem and I already had an IP space I wanted to use, I don't have to use the RFC 19. But for most of us, we're going to want to use RFC 1918. Now, when I think about what is a virtual network, it's a boundary of communication until I start connecting it to other things, other networks, for example. But that virtual network itself, well, it lives within a specific subscription and it lives within a specific region. So I cannot span subscriptions, I cannot span regions. So if I think about what this looks like, I have a subscription. So I purchase an Azure subscription. Maybe that's part of some kind of enterprise agreement or whatever else. So I think about, hey, there's this subscription boundary. Then from a subscription, I can use one or more regions. So I'm going to pick a particular region that I'm going to create my virtual network within. So that's another boundary. And then I can go ahead and actually create my virtual network. So I create my virtual network with one or more IP spaces. So I can create that virtual network with more than one IP space. It doesn't have to just be one. So if I actually jump over to the portal, so here we can see, hey, I'm just looking at the regular Azure portal. If I actually go over and look here, I've got virtual networks on the left, and I'm going to say add. I have to, as always, pick a subscription, pick a resource group. Remember, a resource group is not a boundary of usage. I can put the network in one resource group, but connect resources to that live in another resource group. The resource group is there for manageability. I give it some kind of name, so VNet1. Obviously, you'd have a proper naming convention. You wouldn't call it VNet1. And notice I have to pick the region it exists in. So I've picked the subscription and I've picked the region. Then I pick the IP address space. Now, by default, it's selected a /16. So think of it as the size of a class B network. So this is kind of the subnet mask of 255.255.0.0. Now notice I can add multiple ones though. I could add another IP space in here. Maybe I want to add in that IP space. I could actually add in IPv6 address spaces as well. Notice it's selected one by default for me. And all of these ones that it's automatically added, it's looked at my subscription and it's detected that, hey, you're not already using this space. So it's trying to protect me from myself. It doesn't want me to create VNets with the same IP address space because then I couldn't connect them because they'd be overlapping. So it's trying to protect me from myself. But I can add lots of different IP spaces to this network if I wanted to. So I can add all different things into here, really whatever I wanted to do, and just kind of leverage these. So you would go ahead, often your virtual network would just be one IP space. You don't typically have a whole bunch of these, but I can even add these after the fact. You might, for example, have an existing virtual network you already have, and I can go to my address space and I can add additional ranges. Now, if I've already done things like peering, if I have other connectivity, it will stop me because there's already some exchange of IP spaces happen. There's been checks to say they don't overlap. So there will be times it will stop you. But if I don't have those types of connections, I can absolutely go ahead and add additional IP spaces post creation. So I think about, hey, I create a subscription within a certain region. So if I'm using multiple subscriptions, I'll need a virtual network per region, per subscription. So if I had 2 subscriptions, and in each subscription I'm using 2 regions, well, that's going to be 4 different virtual networks I'll need. Every sub would need a VNet per region that sub is using. And then what I do is I break that virtual network up into subnets, exactly the same way I do as on-prem. I don't just have one giant IP space. We break it up into subnets so we can manage things like broadcast ranges, and break up on when it goes to a gateway to go to other networks, etc. So we do exactly the same thing. I can think about, okay, well, I have my VNet of a bunch of IP spaces, and then essentially I will break that up into subnets. So I'll take a portion of that IP space and I'll kind of create subnet 1. I'll take another portion of that IP space and I'll create subnet 2. And so on and so on. So I'm essentially breaking up this IP space into smaller chunks, and then I'll put things in there. Now, the important thing to note about these subnets are regional as well. The virtual network is regional, the subnet is regional. And why that's important is if I'm using things like availability zones, I can think about how I have this one region, but then to my subscription, what actually kind of happens is I get projected 3 different availability zones. An availability zone are essentially 3 facilities with independent calling power communication. So it gives me some resiliency. So this region, it may be made up of 3 different AZs, AZ1, 2, and 3 within my subscription. Subnets are not bound to a particular availability zone. They still span across them. Now, in my architecture, if I'm using a zonal network service like a NAT gateway, then I would need to make sure when I put resources in the subnet, I only put resources in this subnet that are in AZ1 if I have a NAT gateway in AZ1 and I want to keep the alignment of my resources. That's a more advanced concept that may not fully be clear right now. But just remember that a subnet is not linked to an availability zone. If you need to do that, you'll have to make sure in your placement of resources, you align it based on what resources you put in and what AZ they're in. A subnet on its own, it spans those availability zones. They are regional, just like the virtual network. And that subnet is a portion of the IP spaces of the virtual network. It can't be a different set of IP spaces. It has to come from the virtual network's IP space. So again, subnets regional, they span the availability zones. Now I do quickly want to point out when we create the subnets, ordinarily you create a subnet as a certain / some size. And you always lose 2 IP addresses. You always use kind of the all zeros, which is the network address, and you lose kind of the all ones for the host portion as the network broadcast address. But you also lose another 3 in Azure. The first One is reserved by the Azure default gateway, then the next two are reserved for DNS purposes. So whatever subnet size you create, you're always going to lose out of that size 5 IP addresses. So for example, if you created a /29, well, you're only going to have kind of 3 usable because Azure's taken a whole bunch of them. So normally a /29 would give you 8 usable IP addresses. Well, it would give you 6 usable IP addresses because you lose the first and the last. Well, we'll actually have 3 usable IP addresses because again, Azure is taking them. If I go and look at my networks, let's see if I can quickly find one where I have a really small subnet. We could kind of see that in action. So here you go, tiny subnet. Here you can see I actually did down here a /29, and you can see I have 3 IP addresses available. If you look at kind of any of the others, you can see, hey, I have 251 available. You can see never really more than 251 because again, you're losing the normal 2 you would lose and then 3 more. So you normally with a /24 has 256 addresses. You lose 2 for that network and host, leaving you with 254. Then you lose another 3 for the Azure gateway, and then 2 more to map DNS IPs to the virtual network space. So just when you think about sizing your subnets, make sure you remember that, hey, Azure is going to always take off 5, the 2 you're used to, and 3 more. Okay, so we have now these networks, we have these subnets. Now, what do we do with these things? Now, the IP address always comes from the fabric. So if I think about, okay, well, I want to create resources, I want to use these things on here, I never configure the IP address within the resource itself. There's one time I do in an advanced multiple IP configurations per NIC, but ordinarily, it's always going to come from the fabric. And I mean Azure there. So inside the guest OS, be it Linux or Windows, it's using DHCP, Dynamic Host Configuration Protocol. Basically, it shouts out on the network, hey, can someone give me an IP address? And then Azure will respond, and based, remember, on the IP address of the subnet. So essentially what I'm going to do is I'm going to put a virtual machine, I'm going to place it in a subnet. The reality is actually I place a NIC, a network interface in the subnet, connect the NIC to the subnet, and then connect the NIC to the VM. But to all intents and purposes, I'm kind of putting the VM in the subnet. This will get an IP address from the subnet it's placed in. If I deallocate that VM and start it up again, it might get a completely different IP address the next time. But it's always kind of using that DHCP, and Azure's tracking IP addresses it's already given out and will give it out an available IP address. The first one generally you're going to see given out is a .4, because remember, the first 4 I lose for Azure and just regular IP. So I'll see a .4 if it was a .0 network mask. That will be the first one I ever see given out to a resource. So I connect it into the subnet. Now you might be saying, okay, DHCP, that's okay for some things, but I have resources like a SQL server, like a domain controller. They need the same IP address. There's some countering to that statement to say use DNS names. But then DNS names have a time to live. Some things need to use IP, especially domain controllers and DNS. I want to use that as a DNS server. I can't use a name. I need an IP address. So I can reserve an IP address using Azure Resource Manager. Essentially at the fabric level, like a DHCP reservation, I say this network interface should always be given this particular IP address. So even though the guest operating system says, hey, I'm using DHCP, dynamically give me an address, we're telling the fabric, Azure, hey, when this asks for an IP address, I always want to make sure you give it the same one every single time. And we can see that on the properties of, for example, a virtual machine. So if I jump over for a second and just look at any kind of VM, I'll look at a virtual machine, a domain controller. I can look at its networking. And what I can do is I can look, you can see here, the networking of the virtual machine is actually tied to a particular network interface. And that network interface has one or more IP configurations, in this case just one. And I can see, hey, on this, it has a particular private IP address. And what we can actually do is if I select the network interface, we now open the properties of the NIC itself. I can look at the IP configurations over here in the settings. If I select that, then I can actually look at the IP configuration. So we're digging through a whole bunch of things here. And now we'll see, hey, is the assignment of the IP address dynamic or static? So mine is static and I've set the IP address. So that's how we make sure a resource always gets the same IP address. At the fabric level, I configure that. And I can do that through ARM templates, through PowerShell, generally not going to do it in the portal. You also see this IP forwarding option. This is typically if you have some kind of virtual network appliance that's going to receive traffic, it can forward it on like some sort of gateway firewall device. Most of the time we're not going to use that for regular virtual machines. But that's how I can configure a resource to always have the same IP address, which is something that's going to be super useful if it is one of those special types of resources that can't have its IP address changing. So we can absolutely do that. So VMs can be configured with multiple NICs. Ordinarily, a VM just has one NIC. I think about, hey, yeah, I've got my VM. It's got one NIC. That NIC is connected to a subnet. But there are scenarios you could imagine, if I just draw out for a second, maybe I've got multiple subnets. Let's just draw two for now. Subnet 1 and subnet 2. And remember I said the reality is VMs don't live in a subnet. A VM is a resource. And then what we do is we attach NICs to the virtual machine. Now in this case, I might attach two NICs to the virtual machine, and then we connect NICs to subnets. So if this VM was actually running some kind of network virtual appliance, I might want it connected to multiple networks. So I can actually say, hey, this NIC here, well, you're going to connect to subnet 1. This NIC here, you're going to connect to subnet 2. Now those subnets do have to be part of the same VNet. I cannot take a VM and connect it to multiple virtual networks today. So yes, I can have multiple NICs. I can connect each NIC to different subnets, and I can have more than two depending on the size of the VM. They all have to be in the same virtual network. I cannot span virtual networks today as a single virtual machine. That doesn't mean IP traffic can't flow. IP traffic can flow between virtual networks if I connect the networks, but a particular virtual machine can only have NICs connected to subnets in the same virtual network. So here this VM is now got IP addresses in each subnet and could actually be used to maybe do kind of traffic inspection, enable connectivity between them. It could be an actual appliance that's now connecting. So that's why you can have the idea of multiple NICs for a single virtual machine. Maybe that's like a DMZ, internet facing, and then internet, so it's doing traffic inspection rather than just letting that traffic flow directly through. So I can absolutely have multiple NICs on a virtual machine, and I can have multiple IP configurations on a particular NIC. Things like Kubernetes clusters does this. If you look at a Kubernetes worker node, you can actually see in its IP configurations on its NIC. It has multiple IP configurations to handle all the particular types of networks that it's internally running for the various pods, etc. So again, each NIC can be in different subnets, but it has to be in the same virtual network. Multiple IP configurations. Each IP configuration has a private IP and optionally can have a public IP. So you probably saw when I was showing you that config, there was kind of a public IP option as well. Now I'll talk more about this later on, but essentially the NIC has a private IP. That's an IP address from the IP space of the virtual network. Sometimes you hear this called like a dynamic IP. It's allocated from here. I can also give it a public IP. So a public IP is internet routable. We generally don't like to do it. I generally don't want to give a VM directly a public IP address. It's better to use something like a load balancer, a gateway, a firewall in front of it, rather than having some direct internet connectivity directly into a virtual machine. But you absolutely can, as part of the NIC configuration, in addition to this NIC getting kind of that private IP, if I could spell, from this subnet, I can also allocate, it's called an instance level, because it's at the instance of the VM, public IP. Now, when I do this, the VM does not know it has a public IP. This IP address I configure is not known to the VM. The public IP is still kind of owned by the Azure networking magic that's going on. But what it will do is any traffic that comes into that public IP, it will just pass straight through to that network interface. So the VM knows nothing about this IP address, but it will just process it via that network interface card. So in terms of like network rules, it will be network rules through to the private IP that would actually govern that traffic flow. So for each IP configuration, I have a private IP and I can optionally add a public IP. Again, really don't recommend adding public IPs directly to virtual machines. It's a single point of failure. It's much better to think about, hey, if I want to offer a service publicly, most likely I'm going to want a resilient service and then some kind of load balancer to distribute those requests coming in among multiple VMs. If a VM crashes, the VM's having maintenance, that service still continues to be offered. Where you tend to see this a lot is, hey, I'm setting up a virtual machine. I don't really know what I'm doing. I want to be able to RDP to it from the internet or SSH from the internet. I'll give it a public IP and then I can connect to it. It's terrible. And I'm going to talk more about this. The portal used to do this by default. I don't think it does it anymore. It will just give it a public IP because it has to assume you don't really know what you're doing. You're going to want to connect to your virtual machine. But I really don't want to just stick RDP and SSH on the internet. I'd rather connect via some private means, some bastion, something else. Where I might do this public IP, maybe I want to set up some kind of SFTP server, something like that, and it is just a single instance. But even then, some kind of gateway, some firewall would probably be a good thing. But yes, you can do it. In terms of the types of traffic we can have on a virtual network, so all of the standard IP-based protocols, so IP is layer 3. When we think about our stack, IP is layer 3. So TCP, UDP, ICMP all work within a virtual network. When you start going outside this, things may work because it's still sitting on IP, but then some of the things like load balancers may not support it. Load balancers understand it's a layer 4 construct. So a load balancer understands TCP, it understands UDP. If you go and start doing like SCTP, it doesn't know what that is. It's probably not going to work. I cannot do multicast. I cannot do broadcast. I cannot do IP and IP encapsulated packets. I cannot do GRE. Because behind the scenes, this is what's important to understand. The virtual networks in Azure are software-defined networks. These are not VLANs. This is software-defined networking. This is using encapsulation. This is using GRE to ensure isolation between different virtual networks and different tenants. So I can't do GRE on GRE. So this is all software-defined networking. This is not a separate physical VLAN. There's no layer 2 going on here. This is IP, software-defined networking, providing that isolation. You can't ping the Azure gateways. They're not real. Again, it's a software-defined networking construct. I can't use necessarily things like traceroute to go to that gateway. I can't use a network sniffer in promiscuous mode. Promiscuous mode means, hey, just give me every traffic on this subnet. There is no traffic floating around the subnet. Really behind the scenes, it's all direct via the virtual switch on the physical host. So I can't go and sniff traffic for other boxes. I can't just go and sniff the subnet. So traditional layer 2 VLANs are not supported. There's no concept of that in Azure. The VNet is your isolation. Now I can do things like network security groups I'm going to talk about to control flows of traffic. But the VLAN, that virtual LAN concept, there's no equivalent in Azure necessarily. A virtual network is that unit of isolation. So what about IPv6? We've run out of IPv4 addresses and we're being really greedy. Every fridge and dishwasher has an IP address these days. So IPv6 is galloping in to save us. So as I showed, on a virtual network, on a subnet, I can enable IPv6. It is dual stack. What I mean by that is I cannot just do IPv6. A virtual machine, for example, I can dual stack enable it, but I have to have an IPv4. The Azure management, the health probes, they use IPv4. So I have to be dual stack, IPv4 and IPv6. I cannot just be IPv6. But I can, just like the IPv4 address ranges, I can define IPv6 address ranges for both the VNet and the subnet. It's also supported in things like network security groups, user-defined rules to control routing, load balancers, peering. All of those constructs work across IPv6. Things like virtual machine scale sets, they work with IPv6. Now, AKS, the Azure Kubernetes Service, has some challenges today with IPv6. There's work going on. Obviously, Kubernetes is an open source offering with lots of contributors. That has some work to do around this. But again, that's going to be kind of a dual stack. So again, it cannot be IPv6 only, as I said. I can enable IPv6 for existing resources. So if I have a VM, a NIC, that's IPv4, I can go and turn on IPv6. Now I may have to reboot. The reason I have to reboot really depends on the OS, because it has to now go and also check for an IPv6 address. So that's DHCP, and whether or not it requires a reboot to kind of give it that kick to go and check now for an IPv6 address. Today, ExpressRoute, which we'll talk about, but that's the way to connect on-premises to Azure in a private way, does not support IPv6. That is IPv4. But I can absolutely have public IPs. Public IPs can be IPv4, they can be IPv6. I can create a public IP and say both. I can create prefixes. So I can have kind of that path through from IPv6, from the public to my network through to my resources. One point to note, that when I create subnets, when I assign an IPv6 address space to a subnet, it has to be /64. With IPv4, because we're running out and everything else, you pick the number of bits used for a particular subnet. For IPv6, we're really not expecting to run out ever. I think there's thousands and thousands of IP addresses per square foot of the earth. So I think we should be good. But because of standards, because of interoperation with other technologies, /64 is kind of considered the smallest block we'll use for a subnet, which sounds crazy in a way that, hey, a /64 is the smallest we're going to use for a subnet, given that IPv4, the entire address space, is smaller than that. But there you go. When we create subnets, we'll create them as /64s in size. It has to be exactly. It can't be bigger, can't be smaller. Every subnet will be a /64. Okay, so what about external access? Now I talked about, well, I can give things a public IP address, but I also said we generally don't want to do that. If I have an on-premises location and I want to use things in Azure, I don't want to go out via the internet and back in again. Now, there will be times I want things in Azure that are public facing. Some web-based service, absolutely. That's where I would use a public IP address on a load balancer or gateway that goes and talks to back-end services. But if I want to use those Azure resources from my network, I don't want to go out via the internet. Now, when I do talk about things in Azure being available to the internet, there is no special DMZ where I get public IP addresses. Essentially, every subnet in Azure is created equally. Any resource in any subnet can be given a public IP address. So I could think about, okay, I'm going to create a load balancer. Maybe I have a bunch of resources in this subnet. And I can absolutely go ahead and create like an Azure load balancer that's external facing. So it has kind of a public IP, and it would then, as a backend set, talk to those virtual machines. So that's where that load balancer has the public IP. But likewise, I could give that NIC here, allocate a public IP to it. I could give one to that one. There's no special subnet that is externally facing. I could give anything a public IP address I wanted to. Now, that does not mean I have to have a public IP address to talk to the internet. This is about, hey, something is out on the internet and I want to be able to offer services to it. So I want people to come this way and make requests to services I'm offering in Azure. So I have to have a publicly routable IP addresses that people on the internet can talk to. They'd probably resolve it from a DNS name, and then it resolves to stuff. But if I'm in the virtual network and I want to go out to the internet, I do not need a public IP address. I do not need to be in a special subnet. I can automatically access the internet. Behind the scenes, Azure will enable SNAT and PNAT depending on what I have, so I can get to the internet and it's stateful. It will let the response come back to me. If I'm a resource that has a public IP address, then it will use that for me to get outbound to the internet. So that's the public IP that will be seen from the internet when I make a request. If I'm on virtual machines behind a load balancer, if it's a basic load balancer and it has a public IP, I'm going to use the public IP of the load balancer. If it doesn't have a public IP, it will automatically get kind of allocated one and I will use the load balancer. If it's a standard load balancer, not basic, if it has a public IP, I will use the load balancer. If it does not have a public IP, they won't have any access to the internet. I'd have to do something else. Either I add an external facing load balancer that has a public IP and I can do outbound rules, or I could add like a NAT gateway to the subnet and use that for outbound communications. If the VMs are not behind a load balancer and don't have a public IP, Azure will automatically allocate a public IP address to provide them access outbound to the internet. It will do that source network address translation, the port address translation to enable them to get to and receive the responses. So I do not have to do anything for things to talk outbound to the internet and get a response. I can block it. If I don't want them to be able to do that, then I can use network security groups to control that flow. I could do routing changes to redirect where requests to the internet would go to. But by default, I don't have to do anything. I can deploy VMs, they can go and get to Windows Update or anything else to get those internet-based resources. So there's no special kind of DMZ subnet I have to worry about. So by default, Azure provides that stateful-based connectivity to just allow the response to come back. But to provide services to the internet, right, you have to give it an instance level public IP, which we don't like. Remember, the bad thing is it's a VM has that public IP. If that VM goes down, blah. I place them behind a load balancer, a gateway, a network virtual appliance that has the public IP to make it more resilient. Use a network virtual appliance with a public IP. So I have those different options. Really take care of what you expose to the internet. If I am going to offer services outbound to the internet, so hey, I want to offer something, most of the time what we're going to be offering is things like 443. I want encrypted traffic to come in. That's all I'm going to accept. I probably don't want to just open up RDP, SSH, WinRM. If you do that, it's a great way to test how good your passwords are, because you're going to get hacked. There's constantly scans going on. It's going to find that, hey, there's this opening for RDP and SSH. You can change the port and try and be clever and try and obfuscate it. It won't work. They'll find it because they use port scanners and look for responses, and they're going to attack it. Now, I totally understand. There may be times I have to connect to it from the internet. I don't have private connectivity set up yet. This is kind of my only option. If we are going to do that, there are ways to do it securely, or at least more secure. There are things like just-in-time access. With just-in-time access, I'll show this quick. What I can actually do, I'll jump over to this VM. So what we have here is, as we look at this, I've enabled this. This is part of Security Center. So if I go to Security Center, we can see I've got all these different solutions. If I look at Azure Defender, I have various options here, but one of them is just-in-time VM access. And if I look at this, it will show me the VMs that have public IP addresses and where I've basically enabled that connectivity to. So what this does is, rather than just always having some opening to the internet, what I can do is, hey, look, when I want to actually connect, I can go to the resource and I can say, hey, I want to connect, but it's going to tell me, hey, first, I want you to open up using my IP only. I'm going to request access. And then depending on my configuration, it will open it up from an hour or 2 hours, but it's only from my IP. No other IP on the internet would actually be able to connect to. Now, obviously, if I'm sitting in McDonald's or Starbucks on their Wi-Fi, I'm sharing their outbound public IP. So if I'm really unlucky, someone else sitting next to me tries to kind of connect to my VM at the same time. That's pretty unlikely. And again, it's only open for a small window of time. So if I have to open things up to the internet for RDP, SSH, you can use things like this just-in-time protection. Go in and say, hey, I want to open up access to my public IP for a limited window. You could manually go in and set up a network security group rule, look up what your public-facing IP is, add that as an exception, and then remember to disable it. But the danger there is you forget to disable it. But definitely don't just open up internet facing. It's probably going to be a bad day. Okay, so we talked about how we can enable connectivity to virtual machines, and yes, that is one option for how I could get to things from on-premises. What we're going to talk about in a second is the idea of that private connectivity from on-prem to things in Azure. But first, what about connecting virtual networks together? Remember, if we have multiple subscriptions, if we're using multiple regions, we're going to end up with multiple virtual networks. And I know I talked about kind of putting a virtual machine in a subnet, but many other types of services use virtual networks. I mean, virtual machine scale sets, which is automated deployments of VMs, Azure Kubernetes service, those worker nodes of VMs, Lots of app services can go and integrate with the virtual networks. There's many times we're going to use virtual networks. Nearly every type of architecture will use a virtual network. So if I have multiple subscriptions, multiple regions, I'm going to end up with multiple virtual networks. And a lot of times I might want them to connect to each other. Now in the past, what we would do is we could kind of use a site-to-site VPN, or we could connect them to the same express route circuit. So I could think about, well, I end up with multiple virtual networks. This could be because of multiple subscriptions, could be multiple regions, could be a combination. So I could think about, hey, I had this subnet, I had this subnet, I had this subnet. I'm saying subnet, I mean VNet. So I had 4 different virtual networks. And to connect them, one option was site-to-site VPN. When I use site-to-site VPN, I essentially have kind of a gateway subnet in each virtual network. In that gateway subnet, these automatic appliances are created for us to act as the gateways. So in this gateway subnet, I actually have gateways. And what I would essentially have to do is create site-to-site VPN connections between them. If I use the route-based, I can have multiple connections. So I could have, hey, I'll have a connection to that virtual network and a connection to that virtual network, and hey, I'll connect to that one as well. Well, this one could add, I mean, I could create these sets of connections, but obviously I'm restricted to the performance of that gateway set of appliances in there. They have a certain bandwidth. So even if these virtual networks were in the same region and they could kind of see each other from a software-defined networking perspective, the bandwidth would be restricted to whatever those gateway appliances could actually do. And I pick the skew when I create those. Another option was, well, instead of doing kind of a site-to-site VPN and connecting them to each other, the other thing you could kind of do is, well, I still have these multiple virtual networks. They're all still there. But what I can think about is, hey, we have this big Azure backbone network. And what I can do is there are these things called meet me locations. They're peering points. And ordinarily, and we're going to cover this later on, this is very useful if I have an on-prem network. I extend my network to this peering location. Well, this now gives me connectivity to things connected via that. And what I would very commonly do is, hey, this virtual network, I can do something called private peering. So the private peering would say, hey, this gateway is essentially going to give me connectivity through this. So it would essentially give me a connection all the way through. Well, if I connected multiple virtual networks through separate gateways to the same circuit, so I can kind of imagine for a moment I have a particular express route circuit, I can have multiple connections to that circuit. So if I connected multiple express route gateways to the same express route, we'll actually just call this a particular circuit here, through the same meet me, well, they could actually talk to each other. Now the traffic will hairpin via the meet me location. So if you think about that for a second, let's imagine, just for the sake of argument, these were all in South Central US. And I had multiple virtual networks, maybe it's 4 different subscriptions. And then imagine my facility is in Dallas. So my meet me location is in Dallas as well. I want it kind of close to my facility. It then gets as quickly onto the Azure backbone network. So if I took this approach to connect the virtual networks together, when this virtual network wants to talk to that network, even though they're in the same physical facility, for them to talk, that traffic would bounce via the meet me location in Dallas, where it would then be sent back up. So if you can think about it from a latency perspective, that's really not that great. So yes, there are things we can do. I can put them on the same express route circuit, but then they have to talk via the peering location. I can use a site-to-site VPN, but now I'm using up the bandwidth capacity of those VPN gateways. So that's not really a great solution either. So what we want to do is virtual network peering. Virtual network peering lets me connect virtual networks in the same region or different regions with global VNet peering. There is a small ingress-egress charge for the data. I pay for it going out of my VNet. I pay for it coming into a VNet. But this now is all on the backbone Azure network. It's at whatever performance those virtual machines are capable of. Now the IP addresses cannot overlap. I cannot overlap those IP ranges and peer them together. How would it route? This can span subscriptions. It can span Azure AD tenants. The peers are not transitive, but they could be. So if I go back to this picture, we kind of agree this is not a good thing. I don't want to use site-to-site. I don't want to use ExpressRoute. So imagine for a second, let's just say I have kind of a hub main VNet. And then I've got, we'll just say two others for the sake of simplicity. I have kind of a spoke A VNet and a spoke B VNet. There could be different regions, different subscriptions, different tenants. It doesn't matter. I can set up peering. So I set up VNet peering between them. Again, the IP space cannot overlap. They have to be unique IP spaces. But now resources in here can talk to resources in here. Resources in here can talk to resources in here without doing anything else and operating at the full bandwidth, the full capacity of whatever that resource, that NIC, that VM size. It's just going over the Azure backbone, locally the network. Spoke A cannot talk to Spoke B. It is not transitive. Just because they trust the same hub does not mean they can speak. So this communication does not exist. If I want them to be able to speak directly, well, I have to add a peering relationship between them as well. So I have to go and do that. So I could create essentially a mesh. Now there is other options around this. If you did Azure Virtual WAN, and I cover this in a separate video, it automatically enables these to be transitive by doing something special in the hub. So let's talk about what I can do. But remember, by default, if I do nothing else, that it is not transitive. But let's say I don't want to do this. I don't want to have to set up all of these separate peering relationships. So what I can have in the hub, and we kind of referenced this earlier when I talked about network virtual appliances, I can set up some kind of appliance. This could be something like Azure Firewall. This could be a network virtual appliance from the marketplace. And I'm going to combine this with something called user-defined routing. And what user-defined routing does, everything in Azure, the reason these IP spaces can't overlap is it exchanges routing information. It works out a route table. And what I can do is I can say, well, we'll throw out some IP spaces. Let's say, for example, this is 10.0.1.0/24, and this is 10.0.2.0/24, and we just call this 10.0.0.0/24. What I want to be able to say is, look, if you're in spoke A, if you want to get to spoke B, you need to talk via this. Now, this appliance here will forward traffic. It knows its job is to maybe inspect, but then forward traffic on. So we could say, well, this thing has an IP address, 10.0.0. We call it 10. So what I can do is I can create a route table. And a route table enables me to say for this particular IP space, this is your next hop. Next hop means this is where you send the traffic to. That's the next place it's going to go. So what I could say is I could have a route table in here that says, hey, to get to 10.0.2.0/24, you need to send the traffic to 10.0.0.10. So if I'm trying to get to something that's in the 10.0.2 network, I'm just going to forward it to this resource. This resource knows, hey, I'll forward it over to there. You could think about this could be one of those VMs with multiple NICs, and there's other ways this can be done. On this network, I would create a route table that says, hey, to get to 10.0.1.0/24, i.e. this address space, once again, I send it to 10.0.0.10. You'll notice it's kind of this .10 network. It doesn't have to have a NIC in each network. There are some types of appliance that will. You don't have to. The next hop does not have to be in my subnet. That's the great thing about software-defined networking. It can kind of bend some of those rules that we're used to in a physical networking world. So what I've done is, even though peering is now not natively transitive, it will then route via this appliance. Now you do have to consider, with the Azure Firewall, if doing the job, it automatically scales, you're not going to see a problem. If I was using a network virtual appliance, remember, if I'm doing a lot of traffic, it's going to go, that appliance is essentially one or more VMs, probably multiple VMs behind a load balancer. It has a certain capacity. So I'm doing a ton of traffic. Just make sure you're scaling that NVA solution the right way so it can handle whatever I'm throwing at it. So just make sure you scale all the components kind of the right way. This peering is very simple to set up. Again, I've got a separate video on this, but essentially I set it up that way and then this way. Now, if I have permissions in both virtual networks, I can just create it in one go. Additionally, I actually have to have a permission. Let's say I'm this network administrator, I can't just create a peer to this virtual network. I can't even make the request. There's a limited permission that I need to actually connect to that virtual network. And the documentation goes through all of them. You can create a custom role. I've done it for some of my customers where it just has two actions in it. There's like a peering action, request, and I have to be able to see the network. So I can create a custom role that lets me peer this way, and then I would give these network admins the same role on my network so they could peer that way so we can complete the peering relationship. But essentially, I need permission to kind of lasso out to that network, and then they need the same to come back to me. Again, if I'm a permissions on both, I can just create it in kind of one go. But now I've connected these networks together. And I can go one step further. Imagine for a second, remember we talked about, hey, I kind of got maybe on-prem, and I talked about, hey, there's this great big Azure backbone network that kind of Azure is connected to all the regions. This is within a region or multiple regions. But in this one, we have kind of this subnet gateway, and we have the gateway appliance for ExpressRoute. So if I had kind of an ExpressRoute connection in this hub network that was connected to my on-prem, and I had private peering set up, I can actually do something on these spoke networks. I can kind of say, hey, look, I want you to use remote gateway. So they're now going to use the gateway of the network they're connected to. And on this one, I'm going to allow gateway transit. I'm going to allow them to actually come and connect in and use my connection. So now I have one gateway but my spoke networks would actually be able to use it. So that's a great thing about peering, that I don't have to now connect all of them to ExpressRoute. I can just have that one gateway, and that gateway costs me money, so this is a good thing. I have the one gateway, I can control the traffic that's coming in, I can inspect it. It has the connection via the meet me, the peering point, and then my spokes can use it. So this is a super common pattern you'll kind of see time and time again. But that peering is really key to lighting this up. So I mentioned ExpressRoute, I mentioned site-to-site VPN a couple of times now. So let's dive into that a little bit. Let's actually think about connecting to on-premises. So yes, we talked about internet facing, we talked about how we can give things a public IP. I don't want to do that. That's not the way I want to give access to things from my on-prem, just to go and use things in Azure. I want to think in a lot of ways about extending my on-prem network so Azure is just part of it. I want to be able to connect to things over that private network. So a number of ways we can connect to things in virtual networks from on-prem. I can do a point-to-site VPN. So we have this idea that I can download a VPN client, and then if I'm just an individual machine, for example, I could, hey, my machine over here, it's just me. I can light up a point-to-site VPN connection. So point-to-site means I'm not connecting an entire network. My machine will be given an IP address from a pool that the VPN, so the VPN is different from the ExpressRoute gateway. It's a separate gateway, but I can have both, as long as the gateway subnet's big enough. This machine gets a connection to this network. It gets an IP space from a pool that's reserved for point-to-site VPN. So if I had individual contractors that just needed to get access to the VNet and anything peered to it, connected to it, I could do a point-to-site VPN. I could do a site-to-site VPN. So a site-to-site VPN, as the name suggests, is connecting an IP space of a network to Azure. So in this case, I could think about, well, instead of this ExpressRoute, I have some location over here. They have kind of a VPN device, and that VPN device is going to establish a tunnel. So it's going to be IPsec tunnel. This gets known as an IP space to here. So now anything on this network can now talk to anything on this. And if it's kind of the route based, not static, it can go and talk to all of the other things as well. So if I have some location, maybe ExpressRoute doesn't make sense for me. Maybe ExpressRoute is too expensive. I can use site-to-site VPN. Hey, I'm just going to go and connect my IP space on-prem to my virtual network. So that's absolutely an option. Now, this site-to-site VPN gateways, there's different types of them. And again, I want that route, I think I said policy. So you want that route-based lets me have multiple connections. Policy is static. It's route-based is dynamic. It kind of exchanges lists of routes. So there's a whole bunch of these different gateways. So if we take a quick look at this, here we can see, if we scroll down for a second. So I can see there's basic, kind of don't really worry about basic that much, but there's like VPN gateway 1, 2, 3, 4, 5. You can see the bandwidth changes depending on which SKU I buy. So the higher the SKU, well, the more bandwidth I get. You'll also notice things like the number of site-to-site tunnels goes up as well. Hey, look, there's 30 maximum instead of 10. And the number of point-to-site connections, that's variable. Now you'll notice where it says things like 1 to 10, again, that's if it's kind of that route-based, not the static policy. point-to-site VPN also requires you to have that route-based. It's not going to work on policy. And then there are some that are AZ resilient. So those gateways actually, there's multiple instances. You can configure them to run in active-active, both with the AZ and non-AZ. And it will actually distribute them over multiple availability zones, so I have resiliency from any kind of single data center failure. So I can go and select these. I would pick the one that makes the most sense based on, well, what is the bandwidth I actually need? Obviously, I don't want to pay for more than I need. I want to make sure I'm hitting that amount of actual traffic. So again, I want to use the route-based if I can. That's going to depend on your hardware, probably on-prem. With the route-based, it exchanges the list of IP spaces, whereas the policy is static. It's a lot more limited. I can just have one connection. I can't do the point-to-site VPN on that. Then we have ExpressRoute. And ExpressRoute would be kind of the Rolls Royce. Site-to-site VPN goes over the internet. It's IPsec encrypted, so it's not really a security problem, but it is going over the internet. So yes, I'm encrypted, but I drew a straight line, but it's really not a straight line. I'm probably bouncing around different gateways, there's different delays, there's latency. Latency is, who knows, it's going to be variable because I'm just bouncing around the internet. Whereas ExpressRoute is a private connection. I'm not bouncing around the internet. ExpressRoute gives me a connection, once again, via a gateway when I'm using this private peering. I talked about this earlier. I can have a circuit with multiple connections. So even though I've got one ExpressRoute circuit, I can actually connect it to multiple virtual networks. Now again, yes, they can talk to each other via that, but it's going to go via that peering point. They're going to get that kind of latency. Most enterprises will leverage ExpressRoute because it's that dedicated connection. It's a private connection. It's not going over the internet, and the latency will be lower and it will be consistent. I have a particular path and I'll always be taking that path. There are different types of ExpressRoute. So I drew kind of these lines. This could be kind of thought about like an Ethernet. So I've got my physical location. I get a connection by a provider to the meet me. And then Microsoft's network, this big backbone, has been extended to that meet me. Then on that network, I do private peering. So private peering is connecting my network to a particular virtual network using that gateway. It's not encrypted. It doesn't need to be because, well, it's not going over the internet. It's a private connection. If you want to, you can combine things like site-to-site VPN and ExpressRoute. So you can do a site-to-site VPN over the ExpressRoute connection, so then it is encrypted. There's capabilities at the provider here. You can do MACsec. So MACsec would encrypt the traffic between you have basically an edge router, and then Microsoft has edge routers. In between that, it's going over kind of the airspace of this meet me, this carrier neutral facility. MACsec will encrypt that traffic between your edge router and Microsoft's edge router, but it's not doing an end-to-end encryption. You would have to go and do that if you wanted to. Generally, most companies don't. They don't need it as a private, dedicated connection to you. Now, if the service you're accessing over that is HTTPS, for example, it's encrypted anyway. If I'm using SMB3 with encryption, it's encrypted anyway. But now I have this dedicated connection. The latency will be consistent and it will be really as low as possible. You pick a meet me location close to your data center. It's getting you on the Microsoft backbone network as quick as possible, which is super fast, and it's going to get you into those regions. Now, super important about ExpressRoute. You are not connecting to a region with ExpressRoute. ExpressRoute is connecting you to the Microsoft backbone. Yes, there is a region that's probably closest to that. And there is a SKU called ExpressRoute Local where I don't pay egress over here, but I can connect to any region in the geopolitical boundary. So if I have a express route circuit and I've chosen Dallas, I can connect to East US, West US, North US. It doesn't matter. I can connect to Canada. If I create one in Europe, I can connect to any country in Europe. If I do Express Route Premium, then I can connect to regions outside my geopolitical boundary. So don't think Express Route is connecting to a particular region. It is not. Express Route connects you to the Microsoft backbone network, and then over that, I can do private peering to particular virtual networks in regions within the geopolitical boundary, or even other geopolitical boundaries if I do Express Route Premium. And I have like an hour-and-a-half Express Route deep dive where I go into way more detail than probably you ever want to know. But if you do, go and check out that video. It's got everything in there. Now, I do want to point out, this traffic is going via the gateway. So that gateway is a certain spec. There's something called FastPath. If I turn FastPath on, it's only available on, I think, the 10 gigabit per second. I have to check that. The traffic does not flow via the gateway. The traffic essentially comes in and goes to the resource. You're removing some of the latency. You're removing maybe even the fact that this 10 gigabit per second gateway is too small. There is still a gateway. I still need the gateway to do BGP, to exchange routing information, have BGP sessions, but the traffic does not flow via it. FastPath does not work for peering. It would not FastPath to other networks that appeared. That would go via the gateway. But ExpressRoute would give me a dedicated connection. There's also something called Microsoft peering. Microsoft peering is about, well, there's other services in Azure. There's things like storage accounts. There's things like SQL. There's all these other things. Ordinarily, I access them via internet endpoints. Well, I could make those advertised via my ExpressRoute connection as well. So now when I want to go and talk to Azure SQL Database or Azure Site Recovery or Azure Backup, it will go via my dedicated connection instead of going via that public-facing service. Now, there are now other ways to achieve this with private endpoints and make these services have an IP address in my VNet, and then I can access it via private peering. But if I don't do that, I can actually make services offer just using Microsoft peering. So we covered a lot of different things on this particular picture. Again, we talked about kind of these route tables. So you can use user-defined routing. I don't have to use it just in this one scenario. I can use user-defined routes to really control, hey, I want things to take certain routes. This is where traffic should go. I can even black hole traffic using a route table. So you can go into Azure, create a route table. So there's different types of hops. There's peerings, there's NVAs, there's various things you can actually go and do with that. But I really can completely control how my traffic flows. Now, one other thing before we move on to kind of controlling the traffic is, for the express route, I drew this kind of direct connection. It was kind of this Ethernet and exchange provider. There are other models. If, for example, maybe today I had multiple locations and my multiple locations were currently connecting using something like an any-to-any, an IPVPN, like an MPLS. If I had an MPLS today, well, I can actually add my MPLS to a Meet Me location to essentially connect it to the back end. I might actually host services at one of these carrier-independent, carrier-neutral facilities, a colo, who might have a connection. So there are different ways to actually get on to that express route. But essentially, once you're doing that, you're getting that direct connection to the Microsoft backbone, and then I can connect to regions and other types of services. So let's think about controlling the traffic flow. We've enabled all these connections, network to network, network to on-prem. By default, the traffic will flow freely within the virtual network. It will flow freely to peered networks. It will flow freely via my express route, my site-to-site VPNs. Any connected network is going to flow. If I want to control the traffic, then I have to do something to control that. Now, there's different methods. I could use something like Azure Firewall or a network virtual appliance to control the flow of traffic. This is where I would use kind of a user-defined route, a route table, to say, hey, the next hop, instead of maybe going via the default to some gateway or the network, always go via this appliance. That appliance could then check, it could maybe do even packet inspection before allowing it through. We can use network security groups, application security groups, service tags. And this is just part of Azure. This is a very popular option. It's not an edge device. So a network security group is essentially a list of rules, and I can either allow or deny the traffic. Now I can apply this at a NIC level of like a virtual machine or the subnet. But the reality is the way the NSG actually works is if we think about, okay, I have my virtual network. So this is my VNet. And then I can think about, well, I divide that up into subnets. And then within that subnet, remember, I essentially create VMs, which are really connected because the NIC is connected to the subnet. Now, when I create a network security group, remember my network security group, my NSG, is really comprised of saying, hey, I have source, destination, kind of protocol, port, and kind of my action. Am I going to allow it or deny it? And often these sources and destinations are kind of CIDR ranges, groups of IP address. Now I create these one or more rules that make up the network security group, and I apply it. Now, if I apply the NSG at the subnet or the NIC, the enforcement is the same. This is not an edge device sitting at the perimeter of the subnet. If I think about the way networking works, I can think, well, there's kind of a Hyper-V box, which is what runs Azure. In there, there's kind of a virtual switch, and then there's a virtual filtering platform as part of that switch. And then you have the VMs. In this virtual filtering platform, that is where the NSGs are enforced as the traffic kind of goes in or out of the NIC. So it doesn't matter if you apply the NSG at the subnet or at the VM level, it's always enforced at the NIC. The NSG management of the subnet just makes it easier to manage. There's zero benefit in putting NSGs on the NIC and the subnet. You're not giving it double protection. It's just enforcing the same rules twice as the traffic goes in and out of the NIC. So I create these NSGs, and I generally, best practice, I apply it at the subnet level so it's easier to manage. Now those NSGs are normally, like I say, made up of these ranges of IP addresses. So if we jump over for a second, so let's take a look at this. So if I actually go and search for NSG, and I'll just look at one, you'll actually see there are some built-in ones. So I've not changed anything about this. I can see there's inbound and outbound rules. Inbound, you can see, well, any port, any protocol, source virtual network, destination virtual network, allow it. Now, virtual network makes you think it's just the VNet. It's actually not. The virtual network is the virtual network and any network it's connected to. This could be through peering, it could be through ExpressRoute. Any known IP space is the virtual network. There's also one called Internet. Internet is anything that is not the virtual network. So just to be super clear on this, if I go back to my whiteboard, in this kind of picture here, where I had my virtual network, peered networks, ExpressRoute connected networks, site-to-site VPN, all of those IP spaces, they are the virtual network. It's known IP space, not the IP space of the virtual network. Virtual network in NSG terms actually means known IP space. So it's important to understand that kind of difference. So you can see there's default rules here, and these default rules basically saying, hey, look, anything within the VNet can talk to each other. The Azure load balancer, there's this special source name load balancer, can talk to anything. Everything else inbound, deny. Now these are the default rules. You can hide the default rules. You can see I have no manual rules defined. Then I have outbound rules. And what this says, look, anything from the virtual network to the virtual network, again, outbound to anything within the known IP space is allowed. Anything outbound to the internet is allowed, and this is stateful. So the response will be allowed to come back, even though there's no inbound rule from the internet. It's a stateful service. So NSGs understand, hey, I sent a request, it will let the response come back. Everything else is denied. Now, if I wanted to let something else come in, well, I can add rules. Here we can see the source IP address. I could add a particular IP to allow in. I can say what port it's coming from. I can say the destination, again, IP addresses. And then I could set destination port ranges with the protocols, allow, deny, and priorities. So priority, the lower the number, the higher the priority. If I want to maybe override a different rule, maybe something that's more specific. So here I can have kind of, yes, I can do IP ranges, but you see these kind of service tags. If I select that, there's lots and lots of different service tags. You see all of these kind of generic service tags here, for example, and then you'll see ones that are region specific. So Cosmos DB, Key Vault, SQL, storage. So this essentially would allow me, now inbound is not so likely with storage. For storage, it would probably be an outbound rule. So if I looked at my outbound rule, for example, I might say, hey, from my, whatever this is attached to, i.e. a subnet, I might say, hey, from my virtual network or from maybe a particular IP range within my network, I'm going to allow it maybe to go and talk to certain storage. Again, if I select one, scroll down, I could say storage in South Central US, for example. So these are called service tags. And to make this kind of easy, if I jump over to actually some code for a second, we'll just clear this away. If you think about the Azure public services, they're offered over a whole bunch of public IPs. So what I can actually do is, if I run this piece of code, I'm going to get a list of all of the service tags that exist. And now I want to look at just the ones that are storage for South Central. So it's showing me all of the IP prefixes. And then I could actually go and list those out. So when you use a service tag, what this is really letting you do is, I as a person trying to create a rule have no chance of getting the right IP ranges for storage in South Central. There's too many and they change. So all a service tag lets me do is, when I put in a service tag here for the source or the destination, it's actually mapping to a whole bunch of IP ranges, but it's Microsoft are basically maintaining those. They're maintaining those IP addresses. So when I use a service tag in an NSG rule, it's equating to IP addresses of some service. So, hey, I could think about all of the storage services in South Central US use a whole bunch of different IPs. Those IPs are what map to storage.southcentralus, which I can then use in my rules. So the point of NSGs, I create these list of rules, and I then map them to subnets. And again, I can use IP ranges. So I could say, hey, the IP range of this subnet is not allowed to talk to the IP range of that subnet. Imagine a scenario where maybe let's say I have 3 subnets. And let's say maybe in this one I had a bunch of front-end resources that were internet facing. Maybe this is a bunch of middle tier resources. This is back-end maybe kind of databases. I've got some kind of SQL in here. So with NSGs, I could create a set of rules that could say, look, this IP space at the front end, well, maybe from the internet, it's allowed to receive 443. It's actually offering services to the internet. And again, I'm applying the NSG to all three subnets. They're rules based on the IP range of each subnet. I might say, hey, the front end is allowed to talk to the middle tier subnet. The middle tier is allowed to talk to this one, maybe only port 1433 SQL. I could control that. And I could say the front end is not allowed to talk to the back end. I could actually go and block that. So the point of the NSGs is it lets me control the flow of traffic. So it's super powerful, but I'm really focused on blocks of IP addresses. But you definitely want to use these. Again, it's not a physical appliance. It's not an edge device. It's rules that get enforced in the virtual filtering platform with a virtual switch of the host running your services. So I make them up with these rules. I can also do something called application security groups. So if I think about application security groups, right now I've focused on kind of IP addresses or service tags. And that's great as long as I organize everything very neatly into subnets. But what if I don't? What if things are a bit more scattered around? So what I can do is I can create a tag. I could create a tag. These are called application security groups. I might call it SQL VM or IIS VM. So now in my rules, in addition to IP ranges and service tags, I can say ASG tags. So I could create a rule that says, hey, SQL VMs are allowed to talk to middle tier VMs. Middle tier VMs are allowed to talk to front end or IIS VMs. IIS VMs are not allowed to talk to SQL VMs. I can just put those in my rules instead of worrying about which IP subnet the resources are actually in. So if we jump back over, you can actually see that here. If I go for my source, you can see there's application security groups. And then I could see the one. So I've actually got one called SQL VM. If I look at my application security groups, I can see I've got SQL VM defined in East US, SQL VM in South Central US, Web VM in South Central US, and Quarantine in South Central US. And the way I use these is it's defined on the NIC. So if I go and look at one of my services, I look at the networking. Notice on this network interface here, I have app security groups. So here I can just go and add various ASGs that apply to this NIC. So if I use them in the rules, well, that would then be enforced. I'd then be controlling it for those. So that really simplifies how I can think about this. You notice I had something called quarantine VMs. Why did I have a tag called quarantine VM? Well, imagine a scenario that you have some kind of health check going on. I could have a rule that could kind of say, look, if my source is ASG quarantine VM, then basically block it unless it's talking to maybe a remediation set of resources. And if my health detection detects a VM is unhealthy, all it does is it goes and slaps on quarantine on the NIC, and I'm done. Just by doing that, because all my rules that I've defined and all my resources say, hey, if it's coming from quarantine, slap this thing down, only let it talk to remediation resources, I've essentially put that VM in quarantine just by applying a tag to it. So network security groups, those app security groups are super useful and definitely worth investigating. Okay, so service endpoints and service endpoint policies. NSGs are focused on traffic in and out of the network. And even with those service tags, it was fairly broad. It was storage in South Central. It was not a particular storage account. Many Azure PaaS offerings, including storage and SQL, have their own kind of firewall built in. And I might want to be able to restrict that service, that particular storage account, that particular SQL instance, to only talk to particular subnets. And that's the goal of service endpoints. They make a particular service endpoint known to types of service. Then on a particular service instance, I can say, hey, only allow this one through. So if we go back to our picture here for a second, you can imagine, hey, I've got this subnet. And you can imagine, hey, remember we had storage, but let's just say here I've got storage account 1. Now with NSGs, and this is maybe in South Central US, I could say, hey, only let this subnet talk to storage in South Central US. Great. Now this account also has its own kind of firewall that's in front of it. And I can say only allow certain IPs through. But that doesn't work here. These are internal IP ranges. There's nothing useful I can do here unless I want to try and make it go through some kind of exterior service and bounce back in. No, even when I access exterior facing services in Azure, it doesn't go out to the internet and back. It does stay on the Azure network, but it's not a direct path. It kind of goes around the Azure gateways a little bit. But what I would like to do is say, hey, storage account 1, you can only be talked to from this subnet 3, for example. But to do that, subnet 3 has to be known. The way I do that is I create a service endpoint for storage on that subnet. It's going to do two things. Firstly, now it actually creates an optimal route. Now it's not doing this more wiggly thing. It updates the route table on the subnet to now have a direct route as a next hop of the kind of the service endpoint for the IP addresses, remember those service tags, that make up storage in South Central US. Also now, this subnet is a known entity to the firewall, so it can be allowed or disallowed. So if we jump over, so what we're looking at here is, firstly, if I look at my virtual network and I look at my South Central US, and I can actually go and see service endpoints, you can see I've got some enabled. I've got for storage and I've got for SQL. So now if I go and look at a particular storage account in the region, and if I go and look at its firewall, instead of just being open to all networks, I could now restrict it to selected networks and now add an existing virtual network, pick that network, and it will show me the subnets. Now it will show all of them, but notice there's no endpoint required. I already turned it on. Now it can do both steps for me. It can actually go and turn on the endpoint if it wasn't already. But I can now essentially lock this down so that any other access, unless it's coming from this subnet, would not work. It will be locked down to now only that particular subnet that I have selected. So what it's now giving me is that ability to say, hey, I don't care that it's public facing. The only thing that's allowed to talk to it is the particular network or the particular subnet that I enable. Now, it is important to note these service endpoints are not kind of routable. I have to create the service endpoint in every subnet that wants to talk to that resource. If this VNet was connected to something else, like an on-premises via express route, this could not use that service endpoint. It's only good for that particular storage account, for that particular subnet. Okay, so NSGs, let me say, only talk to storage accounts in this region, okay, or SQL or anything else. Service endpoints with the firewall of the service, say only let this subnet talk to this service. The only gap is that I might have another storage account. I have storage account 2. That's still in South Central US, so the NSG would still let me talk to it. I'm on this subnet and I'm a bad guy. Evil, English accent, probably am the bad guy. And I could, right now, connect to that one from this subnet, copy things and copy it to that storage account because it's South Central US. I'm not restricting it to particular instances of the service. So what we have then are service endpoint policies. Service endpoint policy says, hey, you are allowed to use storage account 1. And I then apply that policy to a subnet. So now I can only talk to storage account 1 from the subnet. I can't get to storage account 2 anymore. So to see these here, if I'm here in the portal, if we just search for service endpoint policies, you can see I've created a policy. The definition, I can say everything in a particular subscription, everything in a resource group, or just a single account. I'm only allowing this particular storage account. And then I take this and I would apply it to a subnet. Essentially then I'm locking down that subnet to just the service instances that I'm defining in that policy. So those things together are really, really powerful. So I'm using the firewall on the service, and now I've locked it down to just particular instances. Okay, that's great. There's one more thing I want to talk about, but before I do, I want to quickly talk about DNS. Virtual networks can use Azure DNS built in or custom. In the network properties, I can select use a custom DNS and point it. I do in mine. I use my Active Directory domain controllers. At a NIC level, I can override that. So I can actually say, hey, this particular VM uses a different DNS config from what the network. This might be I have special types of service, maybe domain controllers, they need a different config. Never ever set DNS within the VM itself. Very bad things can happen. If I need to override, I can set it at the NIC level of the virtual machine. Now, Azure DNS has both public, so I can create zones that are available to the internet, just very standard records, kind of host records, A records. Or I can have private DNS zones. Private DNS zones are very rich. I can create all different types of records, and then I can link them to particular virtual networks, but they're only usable within Azure. Now, with a private DNS zone, you pick the name, you have full management of this thing. Now, whether you know it or not, you're already using a private DNS zone, even if you're using custom DNS. So by default, there's an internal.cloudapp.net Azure DNS zone that every virtual network has. Now, if I go to my VM that's in Azure, I am using custom DNS. If I actually open up a command prompt, if I do an ipconfig/all, you can see, hey, yeah, look, I'm at the bottom here, I'm using custom DNS, my domain controllers. However, Azure DNS is always available via 168.63.129.16. Never going to remember that. It's one of those special addresses that's on every VNet. So if I did an NS lookup for one of my records, if I did SAV, Azure, US, South Central, DC01, now normally it would be in my custom zone based on my DNS servers. But what if I look up this cloud app name, if I do internal.cloudapp.net and I query the Azure DNS endpoint on my virtual network, it has a record there as well. I don't want that. I don't use that. It is always there. I cannot turn that thing off. That's the internal special zone that things are used internally. I can't create records in there, but it always exists. So whether we want it or not, we're always using actually a Azure private DNS zone. But we can absolutely add more. So these are useful things. So I could think about, hey, I have my kind of virtual network, and then I can create one or more private DNS zones. So I pick the name. So I pick name.net. These are all internal. I can create all the different types of records, alias, service, resource, text, you name it, I can create those types of records. I have full manageability. So I kind of create this zone, and then what I do is I can link multiple virtual networks to it. So I can link a virtual network to one for auto registration. So these are now the VM names in here. And I say VM names, could be VM scale sets, AKS worker nodes, anything that essentially uses a VM underneath. Will now register vm.name.net. But I can only link to one private for registration. I can link to 1,000 for resolution. So I might have 10 different private DNS zones that other things linked to, or maybe I manually create records. I could resolve name2.net, name3.net, name4.net. Multiple VNets can connect to the same private DNS zone. I can use these across regions, even across tenants, across subscriptions, if I have the right permissions. So I think I can have something like 1,000 networks can resolve from a VNet, and I think 100 can register to. I think of the numbers. Check that. I think that's right. So I can have multiple things connecting, so I get consistent name resolution even between different virtual networks. Why am I bringing this up? Well, it's useful for one thing. In your network, if I'm using Active Directory, honestly, I'm probably going to be using Active Directory for my DNS. I'm probably not using this very much. And remember I talked about that endpoint. I talked about this kind of special address, 168.63.129.16. That is always Azure DNS. I don't care what the IP space your virtual network is. This is Azure DNS. Now, it will only work from within a virtual network. If I had an on-premises network that was connected, an express route, site-to-site VPN, whatever, it could not use 168.63.129.16. If I wanted to use Azure Private DNS from outside an Azure virtual network, what I could do is I could, inside a virtual machine, install kind of a DNS resolver, set that up to forward to that IP because it's in the VNet, and then configure things to talk to this IP address from on-prem or other networks. So if I want to use Azure Private DNS from outside the VNet, remember I can connect multiple VNets to the same zone, but if it wasn't something in Azure, I can set up a DNS resolver. Why? Why am I even talking about this? Okay, so I talked about VNets, one private, oh, there we go, one private, 1,000. Azure Private Link. Final thing we're going to talk about. So ordinarily, I talked about those external facing services. We can use service endpoints to get direct paths, but it's still essentially coming in through the public IP. I can lock it down. With the service endpoints, I can say only that subnet. It's secure. But some people still don't like the fact that it's coming in via a public IP address. So, Private Link lets me actually create a private endpoint into my virtual network. I can also project custom services. So, remember this picture. Remember the storage account had public-facing IPs, and I could use service endpoints to lock it down. Well, what I could also do is let's have another VNet. And remember that VNet, as always, has those various subnets. For private endpoint, this particular storage account, SA1, I can tell it, hey, I want you to project a private endpoint into that particular subnet. It now gets an IP address from that subnet. I can completely turn off the public facing IP address. It will still show if you do an NS lookup for the name, but it's completely unusable. It's now locked down to just that private IP. So now things in the VNet can talk to that IP address instead to get to that particular instance. It's per instance. The private endpoint IP is for a particular instance, storage count 1. Any networks that appeared to it would be able to talk to that IP. Any other networks that were connected to it via like a site-to-site VPN, express route, would also be able to get to it. So whereas those service endpoints only work from the subnet, this is an IP address. It's an IP address in this IP space. Anything that can route to that IP address can get to that service. But there's one other part. Ordinarily, your services have a DNS name. So this was called storage account 1, and it was blob. It would be storage account 1.blob.core.windows.net. When I turn on private link, a new zone is created. With private link, there is now a SA1 in .private link. .blob, .core, the rest of it. And it creates an alias for the regular record that now points to this. So the point is, I have to have this consistent DNS resolution as well. When I create a private endpoint, it's going to give me a choice. It's going to say, hey, do you want us to manage this for you? If you say yes, well then this here, this zone will get created as an Azure private DNS zone, and it will link it to the network, and then I could link other networks to it as well. What about things that aren't VNets? Well, that's where the other option is, rather than using Azure DNS, I could just create a zone called private link.blob.core.windows.net on my DNS server, which is what I've done in my environment. So I use AD. And then I add a host record, an A record for SA1 that resolves to this IP address it got. That's how I do it in my environment. But if you really wanted to use Azure Private DNS from on-prem, well, you would go and create that resolver. There we go. I drew over here. And it would go and forward to Azure DNS to be able to resolve to it. So private endpoint takes the service and gives it an IP address in your virtual network. So let's look at that. So here, if I look at this particular, there we go. Okay. So here, if I look at a particular storage account, where's my private demo? Probably guess what's in here. So if I look at this one, I've got a private endpoint for actually both blob and files. So if I look at the blob one, what we'll actually see is, yeah, look, there's an SA private link demo, southcentralus blob.core.windows.net, resolves to IP 10.0.1.4. And that's within this particular virtual network we have up here. So if I take that name for a second and copy that, if I do an NS lookup, you'll see, hey, look, the alias is from the regular .blob.core.windows.net, but actually from my DNS server, this is not Azure DNS, I added a zone for private link.blob.core.windows.net. I added a record for SA privlink demo SUS that resolves to the IP address it told me when it got created. And this doesn't change. It's not going to change. So to prove this, hey, I'm on this VM. If I go and look at private link demo SUS, I can get to the content. And just to prove something else, if I go back to that storage account, if I look at the firewall, it's only allowed from selected networks, and there aren't any. So this is completely blocked. There's no network or IP address that is allowed to talk to this at all. But I'm talking to it because I have a private endpoint. If I try and talk to that same storage account from, let's go over here, let's close that down. So if I just refresh out, go to blob containers of this private one and try and load, it fails. It has no permission. There's no path, even though like I'm a full admin, I can get the access key. There is no path to that account for me. I can only do it via that private endpoint IP. Now again, I could lock this also down with those service endpoints that I talked about before. I still could have done that. But in this case, I've used that private endpoint. The other thing these are actually useful for, imagine I had another virtual network that had some service I wanted to use in here. Now normally I would just peer them together, right? What if they got the same IP address range? I wasn't paying attention, big company, they're the same IP range or they overlap in some way. I can't peer them. So I can use a standard load balancer. It has to be standard. I can create a private link service linked to the load balancer. And now I can project a private endpoint into this network. Now things in here can use it. It will do network address translation. So I don't have to worry about the fact the IP address ranges overlap. It's going to take care of it for me. So it's another really useful use for private endpoints. It's not just exposing Azure services into my virtual network. If I have other virtual networks and it's overlapping in some way, well, I can project it in with a private endpoint. And more services today actually go ahead and support private endpoints. So here I talked about it does the most efficient path. It's instance specific, so I can only allow in where I've got a private endpoint. It removes the need for peering. So it's a super powerful thing. So we covered a huge amount as always. Questions, please post below. But as always, please give it a like, subscribe, comment, and share. And I'll see you at the next video.